Alright, we're going to be delving into a bit more on methods that require parameters. I've given you a bit of an introduction in the previous video, but now we're going to delve more into on methods that have parameters. But first, we need to revisit our moon weight program, which we did in the previous video. Remember, the program is to calculate the user's weight on the moon. User enters the weight, a prompt comes up for display instructions, whether English or Spanish, and then they input the language, and whatever the language code is, that is what the prompt will be, either English or Spanish. Alright, so how many methods did you distinguish in this program? Yeah, just one method, display instructions. And how does one method inform a next method? Here, display instructions is called from the main method. Goes to the main method implementation executes, and then we return back to where it was called. So to what extent will it affect the program if the programmer, which is you, wants to provide feedback to the user in his or her preferred language? And why would you actually want to do this? Well, if you have a look at the mainline logic here, you can see that the output is your weight on the moon would be moon weight, but yet we're asking them for if they are English or Spanish, right? Well, that's a bit silly. Then we must have the output must also be in Spanish if they are Spanish, not only English. So what do we need to do? Improve the moon weight program by making the final output more user-friendly, like the display instructions, right? So several approaches. First approach, we can rewrite the program without including any methods. Well, that's not really going to work. Reason being is that you're not taking the advantage of the benefits provided by modularization. And what are the benefits of modularization? Well, making programs more streamlined and abstract, or a more self-contained unit, like display instructions, that can be easily transported or portable to use in other programs. We can also retain the display instructions method here, but make language code, which is set as local, we can make it global. No, that's not quite a good idea either, because then you're going to lose the portability of this display instructions, because everything used to be contained within one method. We don't have portability of this display instructions method. We can retain the display instructions method as is, but add a section to the main program over here that also asks the user for the preferred language. Well, that just sounds absolutely silly, because the user answering the same question twice. That's not right either. What we can do maybe is store the variable that holds the language code in the main program and maybe pass that into display instructions here. That sounds like we could do something like that. But before we even delve into this whole solving this problem here, I want to go through a bit of theory with you. Now, this is from exercise 2. It's the logic of a program that displays the breakdown of a past amount. So the user enters the dollars, and the dollars is stored into the dollar variable. There is a loop going, so it's going to be continuous until the user presses 0. And then dollars is going to be passed or converted all the way down to numDolls here, and numDolls here is going to be used within our dollar conversion here. And what we do is we're breaking that dollars, which was given by the user, into 20s, 10s, 5s, etc. We're breaking them all down, and then we're outputting how much 20s they need, how much 10s, how much 5s, how much 1s, etc. And then we revert back, or we return back to the mainline logic, and we input the next dollars for the users until he presses 0. Okay, so what is the argument to the method? Well, argument to the method is when we pass a data item, like dollars here, into a method from a calling program. So you can kind of think of this parentheses as a funnel to the method that is being used. The parameter of the method, well, parameter of the method is this parentheses here, is the method receives the data item. So whatever's stored in dollars, let's say $20 is stored in dollars, 20 is converted into dolls. So 20 is being put into dolls over here, this variable, and this variable is what's being used within the method. And then we return back to the mainline logic. To write the declaration for a method that can receive a parameter, you must know two things. One, the type of parameter. In this case, our type of parameter here is a num. So you've got to make sure that this doll's here, num, dollars is num, dollars is num, dollars is declared as a num. Next thing you've got to know is that the local name for the parameter. All right, what's the local name for the parameter? The local name for our parameter is dolls. Okay, so what is now a parameter list? A parameter list is the types and names of the parameter. For example, num dolls. What about my method's signature? Well, my method's signature would be the method's name as well as the parameter list. That will be my method's signature. What do I mean by when I pass by value? Passed by value means that a copy of a value is sent to the method. So dollar is sent to the method and stored in a new memory location accessible to the method only. Here is my new memory location, and that new memory location is accessible to the method only. So each time a method executes, parameter values listed in the method header are redeclared. So this method here, for every single loop that happens, these variables are redeclared. So the parameter variables are redeclared every time this method executes, for every loop until the user presses 0. Methods can require more than one parameter. So you can list the arguments within the method call separated by commas. You can list a data type and local identifier for each parameter within the method's header parentheses. You can separate, as mentioned before, each declaration with a comma, and the data type must be repeated with each parameter. Arguments sent are called actual parameters, whereas variables that accept the parameters in the method are called formal parameters. So let's have a look. Just a small little program here where we compute the text. We input the balance, the rate, and compute text is our method, which receives 2 parameters. Now, these parameters here are actually called the formal parameters, meaning that we have written them, they're formal, they're important, you can port, this method here is portable, so everything's formal about it, if that makes any sense. Whereas here our balance and our rate here, these are our actual parameters, what we're actually passing on, funneling to. So we funnel the balance to amount, we funnel the rate to rate within the compute text. And remember that these are all going to be localized, and these ones are redeclared every time for every loop that happens. See how they are separated by a comma, each parameter within the list. Over here, these are all global variables. You can see that these global variables are being used to calculate some of the tax. All right, how would this be asked in an exam? Well, this is a question from a past exam paper. Write the pseudocode for a method called exam method, which will accept an exam mark for a mark as a parameter. The method should display the following statement on the screen. Welcome to the exam. Well, first thing we need to do is you need to give it a try. So just press pause and give it a try before I give you the answer. So the answer is, we need our method signature. Method signature is our method name with our parameter list. And in this case, they've told us that the method's name is exam method. So exam method got to be exactly the same, and we'll accept exam mark as a parameter. So num mark. And then we output welcome to the exam, and we return. So for 4 marks.